Hi everybody, I'd like to welcome you to this lesson about protons, electrons, and neutrons. As you can see on the figures, you have the orbitals of atoms. Let me share with you about protons, electrons, and neutrons with regards to the definition, location, and its symbol. Let's focus about proton. Proton is a positive charged particle of an atom. Symbol of this, as you can see there, P plus. And its mass is slightly less than that of the neutron and times mass of an electron and located in the nuclei of an atom. So it means to say that the location of proton in the atom is at the nuclei. Remember, the symbol is P plus. The charge is positive. Let's go for the electron. It is a negative charge of an atom. Symbol is E negative. And it moves freely orbiting the nuclei of atom. It is much less massive than protons and neutrons. So remember that the charge of an electron is negative. Its symbol is E negative, and its location in the atom is at the orbiting of its nuclei. Let's proceed for the neutrons. So it is actually uncharged particle that has mass slightly greater than that of the proton. The symbol is N0 and it is located in the nuclei of the atom. Remember, the location of neutrons is in the nuclei and its symbol is N0 and the charge is also 0 or uncharged. In conclusion, you have protons, electrons, and neutrons are the subatomic particles of the atom, or these are all inside the atom. The location of proton and neutrons are in the nuclei. They have different symbols. Remember, proton is P positive, while the neutron is uncharged. On the outside of the nuclei, you have the negative charge of an atom, that is the electron. Remember that this symbol is E negative. So with regards to how big or its size, the smallest of these three is the electron, followed by proton, and slightly bigger is the neutrons. So it means to say that the first is electron, second is proton, and third is the neutrons. I would like to share with you this activity regarding how to count the number of protons, electrons, and neutrons in an atom. The first question is, how many protons are there in the atom? You can see on the right side the figure. So you have to take a look at the indicators first. You have electron, it is indicated by a negative sign, and you have it by color green. For the proton, positive, that's pink color, and neutron, no charge, that's white. So again, how many protons are there in this atom? So take a look at the proton, positive. There are 1, 2, 3, 4, 5, 6 protons in this atom. The second question is, how many electrons are there in this atom? Take a look at the indicator. So you have negative, and of course it is color green. That is outside of the nucleus. So you have 1, 2, 3, 4, 5, and 6. So the answer is there are 6 electrons in this atom. Third question is, how many neutrons are there in this atom? You have to take a look at the indicator again. It has no charge and is color white. It is in the middle, or it's inside the nucleus. So there are 1, 2, 3, 4, 5, and 6. So there are 6 neutrons in this atom. This is another example of the activity that's the same a while ago. So you have to determine the number of protons, electrons, and neutrons. The first question is, how many protons are there in this atom? Take a look at the figure on the right side. You have to take a look at the indicators also. You have the negative for the electron, you have there the positive, and the neutron, no charge. So again, how many protons are there in this atom? There are 3 protons in this atom. It is located in the nucleus. Second question is, how many electrons are there in this atom? Take a look at the electrons. So you have 3 electrons that is outside the nucleus. And third question is, how many neutrons are there in this atom? There are 4 neutrons in this atom. Let's take a look at the indicator for the neutron. Thank you so much for joining with me with regards to the activity, and let's have a little bit of information about atom. So everything around us is made up of tiny particles called atoms. The word atom is from the Greek word atomos. It means that it is the smallest unit of matter and element that makes the identity of the substance or an object. Atoms are composed of 3 types of particles, and these are protons, electrons, and neutrons. These components of the atom are referred as subatomic particles. The table 1 shows the properties of these subatomic particles. The nucleus, which is found at the center of the atom, contains protons. These are positively charged, and neutrons, no charge. As you can see here, this is the table 1 that is all about properties of the 3 subatomic particles, the electron, proton, neutron, and you can see also here the symbols, the charge, the mass in grams, and its location in the atom. Atoms in their stable state are neutral. Its number of protons and electrons are equal. The mass of an atom is solely due to the mass of the proton and neutron. The protons and neutrons are referred as nucleons. The nucleons, which are tightly packed together, form the nucleus within the center of the atom. Thus, much of the mass of an atom is concentrated at the nucleus. Let us take a look back at the properties of electrons, protons, and neutrons. As you can see here, the sizes, that electron is the smallest, followed by proton, which is bigger, and the biggest is the neutron. So, of course, you can see that the charges, they have differences because electron is negative, a proton is positive, and neutron is actually 0. Location of the electron is at the cloud around the nucleus. Proton is at the nucleus, same thing with neutron. The relative mass is for the electron 1 over 1840, while for the proton and neutron they are rounded off to 1. However, they are slightly different to each other. The atom in these figures are actually indicated on the left side, the movement, while on the right side, the locations. Let's take a look at these situations with regards to their location. Electron shell, you have to compare that to the one moving on the left side figure. The location of the nucleus, the proton, neutron, and the location also of the electron that's moving in the electron shell. You have to notice also that the nucleus is moving. It's not constant or stable at the middle. So all of them are moving. But as you can see, the fastest is the electron outside of the atom. In terms of the discovery of the atom, it actually started with Thomson's plum pudding model of the atom, which is actually, as you can see here in these figures, on the left side you have the ball of positive charge, and inside of that are negative electrons. This is how it looks like for the plum pudding model of the atom. And in a analogy, or in reality, you can compare it to a cookie which has a positive pudding, it's the surface, and inside of that are embedded are the negative plums or these chocolate chips. So J.J. Thomson proposed that an atom consists of a positively charged sphere and the electron was embedded into it. The cathode ray tube experiment by Thomson showed that all atoms contain subatomic particles or electrons that are negatively charged. The atom's plum pudding model have negatively charged electrons trapped in a soup filled with a positive effect. J.J. Thomson or Joseph John Thomson model of the atom is the pioneer or discovered the electron way back in 1897 by playing with a tube that was William Crookes, or a cathode ray. He has shown that the cathode rays were charged negatively and examined positively charged neon gas particles. It is also compared to watermelon because the red edible part of the watermelon is compared to a positively charged sphere, and the black seeds that fill the watermelon resemble the electrons of the sphere. You have learned in this lesson that protons, electrons, and neutrons are subatomic particles of an atom. Each of them have their differences, locations, and also the sizes. You also have learned about the history, a little bit about the origin of the atom, or how it's actually happening in our surroundings. So that is actually the composition of matter all around us. Thank you so much and have a wonderful day.